Lesson 4, Switched Networks. In this video lesson, we'll describe with you basics concepts of the switched networks. And first of all, we'll take a look with you for such kind of small animation, which is going to show us how switch is making operation with the frames. In here we have the switch with the 6 ports, and each port has its own sequence number. And we have destination addresses which are learned by our switch. So this is the MAC address table of the switch. And now the frame will come. Now frame will come into the switch port, and switch port, the switch will understand where this frame is going to. Frame goes to EA MAC address, so that switch is able to find where this EA MAC address is monitored or tracked. So it is registered on port 4. So the switch resend this frame to port number 4. And new frame comes to destination EE. So destination EE is bounded with port number 1. Next, destination AB bounds through port number 6. So switch operates in this logic so that it has the MAC address table, and by using this MAC address table, switch is actually making switching. So in comparison with switch, the frame, the hub doesn't have any addressing table, so it is just receiving information from one port and sending information through all other ports. So in case if this device will not be switched but will be the hub, so that packet goes for the frame goes, for example, to port number, to MAC address AB, but it will be just broadcasted to all other ports in case if it is hub. Now we understood how switch is working out. It is working with the help of the MAC address table, but the question is how switch is configured with MAC address table. So does administrator have to do it manually, or are they learned dynamically? So to answer for this question, let's take a look for this slide, and we can see here that the MAC addresses of the switches are dynamically populated. And it means that when you turn on the switch, in the switch we have MAC address table, which is empty. So this is going to be MAC address table. So you just turned on your switch and there is no information about any of these devices. And here we can find out IP address and the MAC address of devices. So we have 3 end devices and we have 3 IP and 3 MAC addresses. So when computer PC0 wants to make communication with PC2, PC0 sends a unicast frame to reach PC2. When this frame is received by the switch, inside the frame there is destination, source and destination MAC addresses. So there will be written source MAC address and destination MAC address. So whereas source MAC address will be as, so I'll just write the last division of MAC address is going to be 12A4, and destination MAC address is going to be 4170. So after our switch received this frame, as we see, we have source MAC address. So switch immediately writes here information about the port FA01, and it is mapping it with the source MAC address 12A4. And then switch has to resend this information to PC2, but it doesn't know about the port FA03 that it is bounded with PC2. Maybe it is on FA02. And then switch has to make a flooding. So switch works as a hub at the first time, and this is just the unicast frames, so both of them unicast frames. With source and destination MAC addresses as you see in the projection. So that switch resend this information flutes to all devices in the network. So in case if you have 20 devices in your network, then all 20 devices will receive this unicast frames. And then PC1 will not react on this communication because it is directed not to this. Okay, they are not same. So that PC2 will give the answer. So that okay, answer from PC2 to PC0. When answer comes to switch through FA03 port, switch immediately writes the information about that port that it is connected to 4170 MAC address. So that afterward our frame can be redirected to PC0 because we already have this information, I mean destination MAC address, which is bounded with FA01 interface port. So that, and afterward, after our switch learned this MAC addresses, in case if PC0 wants to make communication with PC2, so the next time our communication will pass to switch, and switch will immediately redirect it to PC2. And if PC2 wants to make communication with PC0, it also will be done without any fluting because MAC addresses are learned. So we have aging time of the MAC addresses. By default, if I'm not mistaken, it is 120 seconds. And after 120 seconds, this information, this MAC address table, if this addresses are not in use, I mean if these computers are not making communication for 2 minutes, then the MAC addresses are deleted by the switch due to that fact that we have dynamic network, and this computer being connected through FA01, but afterward it can be connected through another port. So that if switch will not forget about this values, then it will think that PC0 always connected to this port, but actually it is maybe connected through FA04, for example. And now let me show you an example from the packet tracer. I prepared for you the packet tracer topology, in which we have same IP addresses and same MAC addresses. And we have to first of all be sure that our switch MAC address table is empty. Show MAC address table command will show us that the switch port is empty. Then we have to make ping from PC0 to PC2. 192.168.1 and 10. And then in our switch, we'll take a look for MAC address table. Oh. Show MAC address table. It's very funny because it is not showing us any value, but if we'll take a look with you for the simulation, and we'll make filtration for ICMP, and if we'll try to send information from PC0 to PC2, the same as we made up ping, we see that we have communication. Alright, if we have communication, then the switch port, switch MAC address table have to be, so here it is. I think that this is just some issues with the packet tracer, and now we may find out MAC addresses of two computers which are dynamically learned by the switch, so that so as you see 12A4 MAC address learned by port FA01, and this MAC address 4170 is learned by port FA03. So we can clear this MAC address table. So first of all, before clearing this MAC address table, let me complete this communication. And now I'm writing clear MAC address table, show MAC address table, shows me that I don't have any values again. And now let me try to make a ping from PC0 to PC1, and we'll just take a look what switch will do with this frame. It is receiving this frame, and after it is received, we can find out here that MAC address of PC0 immediately learned by the switch. Then switch has to do what? It has to send this information to both sides, because switch doesn't know about the MAC address of PC2, and when PC2 will send us a reply, then we will see with you that the MAC address is learned by the switch. So in case if you want your switch to learn about MAC address of PC1, so let's make communication from PC2 to PC1. And here it is. And now we have this value. So this is MAC address of PC1. Let's continue with our lecture. We have two types of the switch forwarding methods. They are store and forward and cut and throw. And whereas store and forward type of the switching method is checking the frame each time when frame comes into the switch. It checks actually the cyclic redundancy check value, which is stored at in the trailer part of the frame. We have the frame check sequence value, and inside this frame check sequence value we have CRC value. So that if we'll just try to take a look one more time for this communication, we have the source and destination MAC addresses. We have data, it's actually the packet inside it, and we have CRC value, which is in the trailer part, and actually the field in which CRC value is stored is called frame check sequence, FCS value, and CRC it is content of this FCS value. Now when switch received the frame, if it is working with store and forward method, when switch received the frame, switch fully receive it and stores in the buffer memory to check is the frame is damaged or not. How it can check it? So we have with you the CRC value, which is calculated by computer and which is written into the frame trailer. Then switch receives this frame and makes calculation of CRC value by itself. If this two CRC values, that CRC which is calculated by computer is equal to the CRC value of the switch calculation, then switch looks for the MAC address table to make switching of this frame. So first CRC checking, then switching table, and only after what switch can resend the frame. Whereas cut throw is the very fast type of communication. So it is quite enough for a switch to receive only 14 first bytes from the header to be able to start to make switching, to find out the destination MAC address of the frame and to just resend the frame. So, and a little bit more information about store and forward switching. We have error checking mechanism, which is actually the frame check sequence displays it in the trailer of the frame, as we mentioned before. And one of the more characteristic about store and forward is that the switch has to store information in the buffer memory, so automatic buffering. And in case if you have the jumbo frame, and the size of it, as you see, can be more than the MTU of the Ethernet, which is 1500 bytes. So that jumbo frame can be 9000 up to 9200 bytes. And in case if the switch is receiving jumbo frame, it has to store this frame in the buffering memory to check the CRC value before it can make the switching. Whereas cut and throw switching, so we have two characteristics of the cut and throw switching: rapid frame forwarding, due to that fact that it is quite enough for the switch to check the destination MAC address, this preamble and destination MAC address. So it is quite enough for having 14 bytes before switch can start to resend the frame, so that it can be situation that half of the frame is just received, or just part of the frame is received and the rest part is in receiving process, but from the other side, switch already redirect the frame and is exiting from the network like a from the switch like a snake. And fragment-free switching is the modified form of the cut and throw switching, in which the switch waits for the collision window, which is equal to 64 bytes, to pass before forwarding the frame. This means that each frame will be checked into the data field to make sure no fragmentation has occurred. And fragment-free switching provides better error checking than cut and throw, with practically no increase in the latency. So it's actually the improvement or enhancement of the cut and throw switching method. Well, when we work with the local area networks, we have two variants of the duplexes. So we have half duplex, where we have the CCNA CD mechanism, like a collision, carrier sense, multi-access with collision detection. So half duplex communication is happening when we have the hop based communication. So if your switch is connected from connects to the hub, so that here we have the collision domain. Here some collisions can be occurred because computer A and computer C, for example, can send information at the same time, and when they will do it, they will have a collision, so there will be jump signals and so on. So unidirectional data flow when we have a half duplex, because only one device can send information at one time, and others are receiving this information. Higher potential for collisions can be occurred, and hub connectivity based. So we have switch and hub. Switch port connects to hub, then it is collision domain. Full duplex, point to point only. So you don't have the collision between switch and switch and switch and the computer, which are working by the full duplex. Attached to the side that switched ports requires full duplex support on both ends, so that if in one side you will have full duplex, in another side you will have half duplex, then you will have half duplex communication. And full duplex is collision free, and collision detect circuit is disabled. So it means that CCNA CD is not working on the full duplex on the switch ports. So that in Catalyst 2960 switches, with which we are working in our laboratory, our switches can make decision to work with the full duplex or the half duplex automatically. And this option is configured by default, so that if your switch is connecting to the half duplex device, so then it's working as a half duplex. If it is connecting to the full duplex, then it can work as the full duplex. And also the switch ports speed can be defined by switch automatically, so that if your switch is connecting, if it has the gigabit port, and if it is connecting to the hub which supports 10 megabits per second, then your switch starts to work as a 10 megabits per second and the half duplex. Well, and now it's time to take a look for the collision domain. Potentially, each switch port is creating the collision domain, because each switch port can be connected to the hub or concentrator or the repeater, and in that case each port will be called the collision domain. So in case, even in case if your switch port is connecting to the point-to-point connection from switch to computer or from switch to switch, even in this case we will have separate collision domains. So look, in this topology we have collision domain 1, collision domain 2, collision domain 3, collision domain 4. In case if you are connecting to the switch hub, and hub connects for a lot of computers, so that this will be one collision domain, because this is separate link on switch port of the switch, and it's creating collision domain, potential collision domain. So here we have a real collision domain, but here we have potential collision domain, because actually here is no collision, so this is collision free link, but it is also called as a collision domain. So that in some cases in your exam you will have a question like this. So you have one hub and it's connecting to a lot of computers, and it's asking you how many collision domains. Oh, it is only one collision domain. But another topology will be looking like this. So you have one switch connects to some devices. And how many collision domains? 1, 2, 3, 4, 5, and 6. So here we'll have 6 collision domains. Here we have 1 collision domains. And also there can be situation like you have one router which is connecting to computer by crossover cable, and it's asking you how many collision domains? 1 collision domain. But if it is situation like router connects to switch and switch connects to 2 computers, how many collision domains? 1, 2, and 3 collision domains. It's time to speak about broadcast domain. Whereas the broadcast domain is the area where our broadcast can work. So we'll take a look for this small topologies which are going to show us the communication in the broadcast domain. So one device is generating broadcast, and this broadcast is just resent to another switch because it is a single network. And other switch is also making this broadcast redirection to all other devices, excluding that port through which our frame came. And the broadcast domain is bordered by the router connectivity, so that in case if you will have here instead of connecting your switch 1 to switch 2 directly, in case if you will have here router, so that you will have 2 broadcast domains, one broadcast domain and second broadcast domain. And in case if you will have such kind of topology, and if you will be asked to answer for question how many broadcast domains, so you can just calculate it: 1, 2, 3, 4, 5. So whereas one broadcast domain will be shared between router 1 and router 2, the same as you have switch 1 and switch 2, which are connected through each other with each other. And if you will be asked to answer for the question how many collision domains do you have, 1, 2, 3, 4, and 5. But if you will be asked to calculate how many broadcast domains do you have in this topology, then it will be only 1. So we have here 5 collision domains and 1 broadcast domain. Also we have such kind of LAN design which is called Borderless LAN Design, which is the property of the Cisco. They created such kind of model of the LAN design which can provide a lot of advantages of the interconnectivity of your devices inside the local area. And here are they. So we have 3 layers: access layer switches, distribution layer switches, and core layer switches, where access layer switches are provide access for end devices. So that switch 1 is the access layer switch and is providing access to end devices. So that the main characteristic of access layer switches to provide access for end devices, where distribution layer switches are interconnecting access layer switches. So they are making distribution between traffic of access layer switches. So, and your switches can be interconnected with redundant links with the backup links, so that if the link between switch 1 and D1 will be damaged, so that your switch may make communication through D2 to reach the S2 or to go to the internet. And the distribution layer is making the distribution. So this is main functional distribution between access layer switches. And core layer switches are making connectivity between distribution layer switches and also they are connecting to the router, and the router itself is connecting to the ISP, to the internet. So we may have two internet service providers, ISP2 and ISP1. So that also I want to mention some characteristics of the access layer switches. The on the access layer switches ports can have the functionality of the port security. So you can make port security configuration that you can say that only this telephone and only this PC's MAC addresses will be able to work with this switch port. And if someone will unplug this cable and plug it to another computer, for example, to the computer who is not the part of this network, then switch port can reject this communication and can say, okay, I don't know about you, I'm not going to give you this access. And also another characteristic of access layer switch, and on which belong to only access layer switch, it is support of the power over Ethernet. So that by Ethernet cable we can provide the data signal and we can provide the power signals. I mean, yeah, we can provide the currency, the electrical signals to give the power supply for our devices. For example, if you are connecting IP camera, so that you just need to have a single cable, Ethernet cable, and by using this Ethernet cable, switch will generate electrical signal to support the power on that device, and also it will provide the signals to send and receive data. Whereas in distribution layer switch, we also have mechanism to of the security. It is called ACL, access control list. Which can make filtration. For example, you can make filtration from this access layer switch to this access layer switch. We can have communication, but from switch 3 access layer switch, we cannot make communication to a core access layer switch. So this kind of filtration can be applied on the distribution layer switches. And characteristics also of access layer switch, it has to be like medium or fast speed. Here we have to have fast speed switches. We have to have faster than the access layer switches. And core layer switches have to be the fastest which you have in your network. So that, and if you'll take a look for models of these switches, it can be Catalyst 2960. Example, here you may have layer 3 switch 35 or 36 60, and here you may have 45 switch or 45 switch which can work as the core layer switch. Sometimes you may have collapsed borderless LAN design, in which you will have collapsed layer. It is core and distribution in one switch, and then you will have access layer switches like this, and access layer switches. So advantages of this borderless LAN design is good scalability, security, maintainability, and manageability, and so on. So it is very good design for the network, and where only access layer switches can provide access for the users, so that you will be sure that all of your port security have to be configured here, and PoE, power over Ethernet, also have to be only here. And it's like, you distinguish the different functionalities of the switches to different switches, so that your network starts to work faster, and you have this hierarchical network design which will help you to troubleshoot the network issues and configure your equipment. This is the end of the chapter Switched Networks. Our next chapter is going to be basic configurations of the switch, including telnet, SSH configuration of the line VTY, and including we have also the port security configuration. I hope that this video been informative for you guys, and I hope to see you again on our next video lesson.